Okay, Assalamualaikum and hi to all. Today we'll continue our lecture with chapter 4, which is alkyne. Okay, upon completion of this course, a student will be able to explain basic concept of structure, chemical bonding, chemical formula, physical property and usage of alkyne. And number 2 is students should be able to name and draw structures of alkyne according to their IUPAC and tribal names. And number 3 is students should be able to recommend specific chemical equations for preparations and reaction of alkyne. Basically, this is the overview of alkyne topics, which consists of general formula, structure and nomenclature, IUPAC and common name of alkyne. Physical properties involve boiling points and solubility of alkyne. Industrial source of acetylene. Preparation of alkyne, which are related to dehydrohalogenation of alkyl halide and alkylation of salt terminal alkyne. And reaction of alkyne involve hydrogenation, halogenation, hydrohalogenation, and hydration. And finally, sources and uses of alkyne. So for the general formula of alkyne, alkyne is a type of organic compound that consists of triple bond, and it is categorized in unsaturated hydrocarbon. For example, here we have 2 carbon, which is ethyne. So this is the name for alkyne. You just substitute A and E, ethane, with Y and E. It will be ethyne. Or this is the common name for ethyne, which is acetylene. So here is ethyne, and here is 1, 2, 3 is propyne. And for example, here you have this structure. Okay, you have triple bond. So first you need to find the longest parent chain. So of course here it has 8 carbon in the longest parent chain. And you also need to locate the location of the substituent. After that, please make sure that the location of the triple bond should be at the lowest number. So, for this question, you need to count from right to left. So, 1, 2, 3. So, at location number 3, you have triple bond. And 3, 4, 1, 2, 3, 4, 5, 6. At location carbon number 6, you have methyl. So you put here 6 methyl of 3 Y and E. Or you can also put 6 methyl dash 3 of octane. Okay, this is the skeletal structure for organic compound of alkyne. And here is the triple bond. Should be the triple bond, the location carbon-carbon triple bond should be the lowest number. So you count from here. 1, 2, 3, 4. So parent name is butyne. And at carbon number 3, you have substituent methyl. Okay, and the naming will be 3-methyl butyne. And for this compound, you have here this triple bond. So in this case, you can determine the location of the triple bond, and please make sure the location of triple bond at lowest number. So it will be 1, 2, 3. 3. So 3, 4, 5, 6, 7, 8. Okay, 3 here. And at location number 5, you have ethyl group. So it will be 5 ethyl. At location number 6, you have 2 methyl groups. So it will be 6 dimethyl oct 3 YNE, or you can write like this, 6 dimethyl dash 3 octine. And compounds with more than one triple bond are called dienes, triines, and so forth. For example, here in this compound, it has 2 triple bond. So you need to locate the location of the triple bond. So it will be penta 1,3. 1,3 is the location of the triple bond. And if you observe 2 triple bond in the structure, you need to put di. So di Y and E. So it will be 2 triple bond here. And for example 5, it has this compound, it has 3 triple bonds. So it will be 1, 2, 3, 4, 5, 6. So the location is 1, 3, 6. And you have here 3 triple bonds. So it will be tri. And at location number 5, you have substituent methyl. So you put here 5 methyl octa 136 triine. And for compound with double and triple bond enine, so you must give the priority to the alkene first. Means that the alkene should has lowest number compared to alkyne. In this case, double bond should be given lowest number compared to triple bond. So that's why you count from here, from right to left, in order to make sure double bond get the lowest location. Number 1, 1, 2, 3, 4, 5, 6. 6 is the location of the triple bond. And how many carbon in this structure? Say 7. So you will put hept. And for this question, here is 1, 2, 3, 4, 5, 6, 7, 8, 9. So here it will be 7 E9. So 1, 2, 3, 4, 5, 6, 6, 6. 5, 6, 6. As you can see here, this case, when you count from left to right, you get set number 1 and 7. So from left to right also 1, 7. In this case, you need to give priority to double bond, because here you count from right to left, you get set number 1 and 7, and left to right you get 1 and also 7. So you need to give the priority to double bond. However, for this example, the set number, if you count from left to right, is 1 and 7. So equal to 8. And if you count from right to left, so it will be 1, 2, 2, 2, 3, 4, 5, 6, 7, 8, 2, 8. It will be 10. So of course here from right to left, the set number will be higher compared if you count from left to right. So of course you choose from left to right in order to get lowest set number, which is 8. So the location of the double bond is at location number 7, and triple bond at location number 1, and here is location of methyl substituent. And this is the nomenclature of alkyne in the form of we call as common name. Okay, what is common name? Common name does not consist any numbering or dash. So as you can see here, this triple bond which contain 2 carbon, we naming as acetylene. And here is methyl. You just put methyl acetylene. And here is dimethyl acetylene because it consists of 2 methyl groups. So you need to put dimethyl acetylene. And for the physical properties, boiling point and solubility, as the molecular weight increase, the boiling point also increase. And the density of alkyne are less than water. If you mix alkyne with water, it will float on the water because its density is less compared to water. And for industrial source of acetylene, so here is the reaction, or we call as the method preparation on how to produce an alkyne. Start from a coke. Coke react with calcium oxide, or other general name we already know as limestone. So this limestone react with a carbon at a very high temperature, which is 2000 degrees C, and it will produce calcium carbide in the presence of carbon monoxide gas. After that, this calcium carbide will react with water to produce acetylene. So acetylene in this reaction will be starting material to all other organic chemistry synthesis for alkyne. So in the preparation of alkyne, it involves two parts, which are dehydrohalogenation of alkyl dihalide and alkylation of salt of terminal alkyne. So basically this is the dehydrohalogenation of alkyl dihalide. So the starting material should be here is alkene, and it's undergo addition of X2, or we call as addition of halogen group in the presence of dichloromethane that act as a solvent, and Br will add to the carbon-carbon double bond to produce alkyl halide. And after that, this alkyl halide will react with sodium ammonium in the presence of ammonia to produce back an alkyne. This is the byproduct of the reaction. Okay, when one butane react with sodium ammonium, it will produce here, this hydrogen will leave the carbon, so it will produce here we call as carbanion, and here it will produce sodium positive charge that come from here. So after that, this acetylite ion, it will be what? So here it will combine with CH3. This CH3 come from where? Come from this one, alkyl halide, to produce 2-pentyne. And reaction of alkyne undergo many of same electrophilic addition as alkene. And the reaction consists of hydrogenation, hydrohalogenation, halogenation, and hydration.